In this video, we're going to solve some exponential functions, all right? We're going to start off with some easy ones, and we're going to work our way to some harder ones, all right? And with this, what you want to do when you're solving exponential functions is you're trying to get the exponents to have the same base. So like in this first one, they already do. They're both going to be 7s, and because of that, obviously I can just say that the top, the exponent, if you will, I can say x equals the other side, x equals 3, right? Now, that's pretty easy on this first one, but the second one, when it says 2 to the negative x equals 16, they don't have the same base. So I have to get both of these to have the same base. Since I can't really make 2 raised to a different power, I'm going to make 16 as 2 raised to some power. So I'm going to keep this side the same is what I'm trying to say. And on the other side over here, 16 is 2 raised to which power? Well, if you think 2, 4, 8, 16, that's 4. All right, so I can say 2 to the 4th power, and because they're now the same base, I can take their exponents and set those equal to each other. I'm going to say negative x equals 4, right? And of course, if I were to divide by negative 1, on both sides there, x equals a negative 4. All right, and then one more here on this first kind of section, we're going to go to some harder ones. This one says 4 to the x equals, or doesn't equal, times 2 to the x squared equals 16 squared. Well, we already did this last one. We got both the 2 and the 16 to be 2 raised to some power. Can I make 4 as also 2 raised to some power? Well, yes, that's 2 squared. And so if I do all that here, this is going to be 2 squared. But what happens with the x? Well, it's going to be multiplied by that exponent that you made, right? 4 to the x is the same as 2 times, or 2 raised to the 2x. Right, over here, this is still going to be 2 to the x squared, right? And like we said earlier, 16 can become 2 to the 4th, but I also have that 2 up there, so I need to multiply it. And then what happens now? Well, these are all going to be the same base, so you can do a couple things to simplify this. Whenever you have a multiplication sign, you can replace that with addition. Remember when we went through our exponent unit, and we said that when you are multiplying with the same base, you add the exponents. Same thing here, okay? So I can add those together. I'm going to say 2x plus x squared equals, and then of course on this side, 4 times 2 is 8. All right, so if we go to solve this one, we're probably gonna have to factor. If I set this equal to 0 by moving the 8 over, I bet we can get this thing to factor. All right, so I'm gonna write this in descending order for my exponents. X squared plus 2x. I'm gonna subtract the 8 over, minus 8 minus 8. All right, so I'm gonna get minus 8 equals 0. And if I come up with some factors here that multiply to be 8 and add to be 2, well, 2 and 4, and I think the 4 would be positive. So if I say x plus 4, x minus 2 equals 0, that should work out, and I think it does. And then set both those equal 0. X plus 4 equals 0, x minus 2 equals 0. Of course, x is going to equal a negative 4, and on this one, x is going to equal a positive 2. So that has 2 answers there. Right, let's try some harder ones. All right, the last 3 that we're going to do are going to be a little bit more challenging here. Starting with this first one, it's more challenging because it has this part that says 1 over 625. All right, so I think we can probably make that as 5 raised to some power. So I'm going to keep this left side the same as 5 raised to the 2x. And over here, if you think about 625, well, you got 5, 25, 125, and then 625. That's going to be 5 to the 4th. But it's on the bottom. So if I just real quick put this down here, like 5 to the 4th on the bottom, not the best 4. Remember when we move it to the top, our exponent switches signs. So, or whatever, if you start at the top, go to the bottom, it switches signs, or if you start on the bottom, go to the top, it switches signs. What I mean by that is I'm going to say 5 to the 2x still, but it's going to equal now on the top 5 to the negative 4. All right, so you just have to kind of remember that rule of exponents, that if you switch sides, the sign also switches. Okay, and if that's true, then I'm going to have 2x equals negative 4, divide by 2, and of course, x equals a negative 2. So once you get that part, the rest of that problem is pretty simple. This next one has base e, all right? Whenever you see an e in the problem, it's always going to be base e. There's really no other way to do that. So I'm going to keep these 2 parts the same. That's already simplified for us. E to the 2x squared equals e to the negative 13x. And then like before, I have to move that to the top. This is going to be times e to the negative 6. Okay, so now all the bases are the same. I'm just going to set those things equal to each other. Remember, negative 13x, when it's being multiplied here, the exponent actually gets added. So if I were to say plus a negative 6, that's the same thing as just minus 6. So be careful with that. I like to keep my x squared term positive, so I'm going to move these two to the other side and get 2x squared plus 13x plus 6 equals 0. Get a better marker here. Try that one. And there we go. And then let's see here. I think I'm going to have to solve by grouping. So that's going to be 12, 13. So I think 12 and 1 are what I'm going to use. So 2x squared plus 12x plus x plus 6. If you forgot how to factor by grouping, I have plenty of videos on those. All right, we're going to group it together first two and the last two. This is an x plus 6, so that's probably what I need here. So I'm going to take out a 2x actually, and leave me with x plus 6. Over here, it's already x plus 6, so I can take out a 1. And let's see, we got 2x on the outside plus 1 times x plus 6 equals 0. Set that equal to 0, you're going to get a negative 1 because you have to subtract it, divided by 2. So a negative 1/2. And on this side, x is going to equal a negative 6. Again, if you forgot how to do some of that factoring, you might want to check out some of my other videos on factor by grouping. All right, this last one that we're going to do today, this says 243 raised to the negative 2x times 9 to the negative 3x equals 81. All right, now you might need to check with the calculator. What I'm seeing right away is that this is 9. I can make this 9 squared. Can you make 243 as 9 raised to something? No, you can't. So, right? So then I might think, well, could I go lower? And 3 kind of pops into my head, right? 9 is 3 squared. So let's see if we can do that. 243 is actually 3 to the 5th power. So if I think this is 3 raised to the 5th, I now have to multiply that by this negative 2x that's already in the exponent. All right, so the 9, like I said earlier, is going to be, oops, not 2, but 3 raised to the 2, or 3 squared, times that negative 3x already in there. And what is 81? 81 is 3 raised to what power? Well, 3, 9, 27, 81 to the 4th. So equals 3 to the 4th. All the bases are the same. So we can go ahead and do the multiplication and then put those things together. Over here, we're going to have negative 10x. Times, remember, means we're adding the exponents. So here it's going to be a negative 6x. So instead of plus and negative, I might just say minus 6x, and then equals the 4 from that exponents. All right, I have just, this one doesn't have an x squared, so we can just put those together and I think solve here. What is negative 10 minus 6? Well, that's a negative 16. X equals 4, divide by negative 16. And we just get a simple negative 1/4 for answer on that one. Hopefully you found this video on solving exponential equations helpful. Until next time, keep doing your math fast and accurately.